Welcome back, everybody. We're talking about friction today. And friction is a force that only acts on moving objects. And the best way to see this is to break up all of the forces acting upon an object and see if there's friction or not. Okay, so if I have a box or a cube sitting on a surface, it's going to have two forces. One of the forces is its weight, and its weight, if you remember, weight equals mg, so it's mass of the object times whatever the pull of gravity is, and on the Earth it's always 9.8. And the reason it's not accelerating through the floor is because there's a support force on the floor called the normal force. And remember, normal is a 90-degree angle. So whatever the 90-degree angle to the surface is normal, and there's a support force, that's why it's not accelerating downward. Okay, so in this case there's no friction, because friction only moves on objects that have a tendency to move forward. And so we're going to be looking at an inclined plane today, because you can imagine eventually if you have an inclined plane, a box would slide down the plane, and we're going to say when it would slide and when it would not slide. So in this case, the block at rest on a horizontal surface, the normal support force N is equal and opposite to W. So whatever W is, N is going to be equal. So this is at a zero incline. There is no friction here because the block doesn't have a tendency to slide. Friction only works opposite to motion. So in a case where there's no tendency to slide, there is no friction. Friction is always a countering force to forward motion. So in this case, number 2, where you start having an incline, now you can imagine that if you had a slight incline, you're not going to have a lot of tendency to slide. The box will just stay put. If you could have a very, very slick surface, you could imagine it's possible that it would slide down. But the steeper it would be, the more tendency it would be to slide. And we'll see that friction it counters because there's a microscopic edge. So let's see that that's the bottom of the box, and this is the bottom of the top of the table. You're going to, even though that it looks perfectly smooth, you're going to have some bumps and dips that work just like Velcro that wants to hold that together. And it takes a big force to be able to actually yank that apart. So continuing with 2, at rest on the incline, friction acts. So once you're on an incline where there is a possibility of moving forward, now you're going to have a friction force. Now let's see why. Normal always acts at a 90-degree angle to the surface. So a normal force would actually be this angle. Okay, so the normal force is acting straight up from the block, exactly out of the surface of the off of the horizontal. But weight always goes towards the center of the Earth. Weight doesn't always go down into the table. If the table is bent, then the weight doesn't go into the table. The weight goes at an angle to the table, and it's always heading towards the surface of the Earth. So you're going to see that there is an equal and opposite. There is an equal and opposite of weight. Whatever weight is down, you're going to have its opposite up because it's not accelerating down. But since this is at an angle, it's actually broken up into two parts. So we're going to make a parallelogram here. And we're going to have this was your resultant, this is y, and this is x. Your y is still the normal force because it's coming directly out of the surface. The surface is 90 degrees to the normal. But you end up with another force, another vector, this vector in the x direction that is opposing motion forward, and it's called friction. Friction always is a rearward force. Wherever motion is going forward, friction is going to act in the back. And you can see where it's coming from. It is simply the x component of the opposite to the weight, so that it's not accelerating down into the table. It's not accelerating down towards the middle of the Earth. It's countered by some kind of a support, and this support is broken into two parts. The normal force is part of the support force, and the friction is actually part of the support force. It's the x component of that force. So at rest on an incline, friction acts. Note that the resultant F plus N is equal to W. So here's the resultant, and it's equal and opposite to W. So whatever its magnitude is, and whatever its angle is, it's going to be exactly 180 degrees away. Okay. So next question. Here we see that the size of N is, okay, now here's W and here's N. The resultant is equal to W, so it's the hypotenuse of that triangle. Do you see that the leg, this is a long leg, but it's not as, it's still, anytime you have a right triangle, you're going to have the hypotenuse is bigger. So now N is actually slightly smaller than W. As this N drops and drops and drops, F is going to start taking over more and more and more. So the steeper this goes, the more friction you're going to have. The more of the friction force you're going to have, but we're going to see it may or may not counter. Okay. Number 3. Draw the resultant for F and M for the block at rest on a steeper incline. Well, if you remember, we're going to make a parallelogram. So we need a parallel line here, and we need a parallel line here, and so the resultant force is here, and it is equal in magnitude and opposite in direction to the weight. So this is your friction, and this is the normal force that's coming out straight out of the surface, 90 degrees to the surface. So in this case, the resultant, which is this guy, is equal and opposite to the magnitude of W. Okay, so the resultant will always be equal and opposite to W. As the angle of the incline increases, the magnitude of N does what? Okay, so the more this is stiff, okay, or more this is steep, what's going to happen? N's going to shrink and F's going to get bigger and bigger and bigger. Eventually, N will go completely to 0 if you make it completely 180 degree angle. So as the incline gets closer and closer and closer to 90, your N is shrinking down to 0. All right. So as the angle of the incline increases, the magnitude of the vector N, okay, decreases. The magnitude decreases. So the block remains at rest on a steeper incline. So it doesn't necessarily mean that it's going to move or not move. You've got to have, if your friction force is stronger than the force that's making it go forward, then it'll still stay there. As soon as the force making it go forward is higher than the friction force, it'll start moving. So you already know that between the normal force and the W force, there is a forward force. We just have to know, is it countered by friction or not? Okay, so let's draw this. Let's see, how does the resultant F plus N compare to W? Well, W is always going towards the center of the earth. That's its weight. This is mg. And normal force is always out of the table. So whatever the support force is, the normal component is exactly 90 degrees. And then in this case, the friction component is always at horizontal to the incline. And then the forward component is going to be coming straight out of here. Now remember, I can make parallelograms here twice. Here's a parallel line. Here's a parallel line. Okay, so I do have some forward thrust, so this could start moving, especially if this were really slick. But I'm also going to have some, I can also draw a parallel line here, and we're going to see that in just a second. How does the resultant compare? Okay, now the resultant, remember, if this is F and this is N, the resultant is going to be equal and opposite. So the resultant has to be the same length of a line as this and in 180 degrees. That means that this is actually a little farther. So something like this. So I've got a normal force acting up and a friction force acting back, equal and opposite to this. So it would be same magnitude and opposite direction. All right, so the idea is that it's going to get steeper and steeper and steeper, and what's going to happen. Suppose the angles increase and the block slides down at a constant velocity. All right, is it accelerating if it's going at a constant velocity? Pretty dumb question. No, it's at a constant velocity. It's not accelerating. That means all the forces are balanced. So let's imagine this guy is going down at a constant velocity. If it's going down at a constant velocity, it's not accelerating in the forward direction. So why is it not accelerating? Because its friction force is exactly the same as its forward thrust. So whatever the direction moving forward, if it's exactly 100% countered by friction, then it will slide at a constant speed and not accelerate. If friction is bigger, then it will slow down and stop. If the forward thrust is bigger than friction, it will actually accelerate. It'll get faster and faster and faster as it goes. So if you throw something out of an airplane, it's not just going to go at constant speed, it's going to get faster because the air friction is actually not as much as what's being accelerated as the object is getting closer to the ground. So the net force on the block, okay, so this is constant velocity. If it's constant velocity, then there's no net force in the forward direction, then the net force is zero. A lot of people really have problems with this. They can't imagine that you could have zero force and it still move. But you can. You can have a zero force and it can be stopped, like it's not moving, or you can have zero force and it is moving, but it would be moving at a constant rate. Last question. Further steepness of the incline. Okay, then what's going to happen? As the further it's steep, then the forward is going to be longer. Your friction is going to remain the same, so it's going to get shorter and shorter and shorter compared to the front, and so it's going to have less of an effect, and you're actually going to accelerate. So you will have more acceleration as steeper it goes, and eventually if it's 180 degree, I mean perfectly straight up and down, then there is no friction on the surface, and you would only end up with air friction. So when the incline is vertical, straight up and down, then acceleration is actually gravity, and that's what you call gravity. This takes a little bit of time. This is not something you can do in one quickie lesson. So if you have some specific questions, please ask me in class.